So the ASTRE project, ASTRE means Analyse Synthèse des Traitements Temps Réel. So it's a project about a very important issue that we have with electronic music in general, or live electronic music, is how are we going to keep these works in the future? Because these are works that really depend on heavily on software parts, and obviously we can keep the files, that's easy, but the problem is that even if you keep the file, languages, programming languages are always evolving. So the meaning of your file, so to speak, evolves also, even if you keep it. For example, maybe every 10 years you have a new version of the C language, for example, that evolves. So even in a short period of time, like 5 or 10 years, there is a possibility that your piece need to be adapted. So it's not necessarily very difficult. The author of the software is still alive, so he's still here, and so generally it's not a problem, but you have to do that. But we are for sure that in maybe 20 years or 25 years, it starts to be much more complex. So the ASTRE project is about trying to find a partial solution to this problem. And the project is really centered about the Faust programming language. And here it's the idea is that programming languages are evolving very fast. But there is another language that evolves, obviously, but in much slowly, and this language is powerful enough to capture all the detail of a software, and this is mathematics. So the idea of ASTRE was, can we build a tool that takes a Faust program and generate a purely mathematical description of this Faust program? The idea is that Faust will evolve and at some point probably will disappear also, but mathematics will stay. So if we can take a program and automatically being able to extract all the information from this program and give a purely very detailed mathematical description of this program, then we will have all the information to rebuild with the new language a program that will behave exactly like the one that we want to preserve. So this is called preservation by abstraction. We abstract the programming language, Faust, in order just to keep the mathematical meaning of the program. So this is this idea of how to preserve software using this system. The implication of that, why can we do that? We can do that because Faust has a well-defined formal semantics. It means that we can compute easily, or relatively easily, the semantics of any Faust program, even a very complex and very big, very large Faust program. It would be much more difficult to do that with a programming language like Max or PD, because the semantics is much more complex. So the lesson, so to speak, that we learned from that project is that our tools should have, if we want to preserve things, our tools should have a well-defined formal semantics. So it means that formal semantics is not just of academic interest, it has also a practical interest. If you have a tool, any tool, used to do art or music, if this tool has a formal semantics, then you are able to preserve mathematically what's done in this tool, and you can do that automatically. So I think that from now, when we design new musical tools, we need to integrate this aspect. We need to integrate this the possibility to express easily the formal semantic of the tool. Any kind of tool should have a well-defined formal semantic so that we can preserve what we are doing with these tools.
So the first, the S3, until now is still built on the C language to describe the mathematical function for every software in the world.
No, these semantic tools are built inside the Faust compiler. So with the Faust tools, you can take any Faust program and say, okay, now create a PDF, a file, a document with all the equations inside that. So just have to press a button and you have this document. So you can keep it in an electronic version, or you can keep the paper version of this documentation. So it's like a kind of a system of documentation, but instead of asking the developer of the software to document everything, this is done automatically. This is the interesting part of the project. We are able to generate documentation automatically, directly from the code, not from comments added by the developer.